Okay, so the chapter which I proposed in the ICDCIT Research Symposium, that is my thesis title, Design of Efficient Algorithms for Mobile Charging in Wireless Sensor Networks. So in this presentation, I will be giving you a brief idea about the introduction and motivation part, why we are doing this research study. Then we will discuss the problem statement and what are the objectives associated with my problem statement. Then we will be discussing about some proposed works, or you can say contributions. Then following by the references and the list of publications. So if we talk about the introduction part, then everybody know that in the wireless sensor network, the serious concern is about the energy of the sensor nodes, because the size of the sensor node is very small and the energy they are storing is very limited. So there is a problem of energy scarcity. Now in the previous research, there are many methods which have been proposed, which have been adopted, like energy consumption reduction, or you can say energy harvesting, or we can say manual battery change. But all these methods are not practically suitable for all kind of conditions. We can say that if we reducing the energy consumption, then it may reduce, it may give energy, it may balance energy to a certain extent of time, but ultimately the sensor will die. If I'm talking about the energy harvesting schemes, then they are depending on the environmental condition. If I'm talking about the manual battery operating, so in unattended area where we cannot easily approach, where we cannot easily reach, so it is not possible always to replace the battery of the sensor nodes. So we are only left with the solution, that is energy provisioning. We have to supply energy to the sensor nodes, and we are thankful to the advancement of wireless energy transfer, that is WET, and the rechargeable lithium battery. Because of these both innovations, we are now capable of doing the wireless charging of sensor nodes. And if we are integrating this particular advancement to a WSN, the whole paradigm is known as wireless rechargeable sensor networks. And in the wireless rechargeable sensor network, one or more mobile chargers, they supply energy to the nodes in the close proximity, because there is a range of wireless charging. Let's say 10 meters, 5 meters. So either it will be applicable for one mobile charger or multiple mobile charger, depending on the area size it is actually using for the charging of the sensor nodes. Now if we talk about the charging scheduling problem, then the main problem is that there are many sensor nodes, they are depleting their energy. Now after a certain point of time, there are many critical nodes. Now we have to decide which sensor node should get the energy first, which is more critical. So we have to schedule the charging of the sensor nodes. So what we are given? We are given a functional WRSN. It is already working. We have already, the data is already flowing from sensor node to base station. Already there are multiple MCs, they are adopted in the network. Now we have to decide what should be the order of the charging of the nodes, because order is very much important. If the order is efficient, we can say we are maximizing the overall charging performance. If the order is not good, then we may end up as reducing the performance. I mean, we cannot get the maximum advantage of mobile charger. So we have to work on that. And I am just explaining the strengths of WRSN. Here you can see that there are many sensor nodes, and the battery size is also reflected in the diagram. With the red color, we are just highlighting those sensor nodes which needs to be recharged, which have less battery. Now in the first figure, in the A, the sensor nodes and the battery level is given, a mobile charger is given, The mobile charger is initially at the base station. In the second diagram, you can see the schedule. It is starting from the base station. It is going to the first sensor node, the second, then third, as per the schedule. Directed graph. So that schedule is important. We have to design that schedule. We have to determine that schedule. Now, there are many types of charging schemes. In the past, there have been developed periodic schemes and on-demand schemes. Periodic means we are periodically we are charging the sensor nodes, but the on-demand is very much practical in the dynamic scenario because we are only charging the critical loads. Whenever they are sending the charging request, we are charging them. Now we can use the single MC, we can use the multiple MCs. We can use the single node charging as well as we can do the multi-node charging. Multi-node means we can charge multiple nodes at the same time, and that is giving the more performance as comparison to single node charging. And fourth one is full charging versus partial charging. We can fully charge a sensor node or we can partially charging sensor nodes. So I have worked in the full charging concept. So both the things have pros and cons. If I am fully charging, so I need not to come to the sensor nodes again and again, but I may be left off to charge some nodes. But in the partial charging, I am giving only that amount of energy that is actually required at that time. So by that I am overall reducing the traveling. But it may be a situation that sensor nodes may drain up energy very fast again and again I have to go to there. So both have its benefits or you can say some disadvantages also. Now, what are the gaps which we are filling, or you can say motivation? We are developing efficient periodical charging schemes and we are developing efficient on-demand charging schemes. In the periodical, what we are doing, we are using multiple MCs. They are distributed in the network, and the overall objective is that we are balancing the traffic load of the sensor nodes. Traffic load means the routing load. How much data a sensor is forwarding to the base station. So that traffic load should be balanced. And second, we are using multi-node energy transfer, which is more beneficial as compared to single node charging. Like this, we are also developing on demand in that we are making scheduling decisions based on multiple network attributes. So that is the point. We should use multiple attributes. And we are balancing the charging workload among the MC. It should not be the case that one MC is charging 10 to 20 sensor nodes and one MC is charging only 3 to 4 sensor nodes. We should make a balance among all the MCs. We are also dealing with the heterogeneous energy consumption rate because that is the situation in the dynamic scenario. While a sensor network is always dynamic, so in practical situations, we have to deal with the heterogeneous energy consumption rates. And also it is given that MC's energy is very limited. So we have to work on both the scenarios. And lastly, we are ensuring the feasibility of the nodes for avoiding unnecessary MC widget. Because we have to optimize the traveling also. Whether a node is feasible to be scheduled or not, we have to decide. Otherwise, we are wasting the resources. So all these objectives have been covered in this thesis, or you can say in the chapter. Now, contributions. If we talk about the brief contribution, then periodic, we are just dividing the scheme into two parts. That's the network partitioning and trajectory design. And in the case of on-demand, I am using MADM, that is multi-attribute decision making approaches, and I am using fuzzy logic. And on these both types, I have devised two schemes, one considering the objective attributes and second considering the subjective attributes in the case of MADM. And while in the case of fuzzy logic, I have developed one scheme from single MC, one scheme for multiple MCs. So I have considered all the possible scenarios. So in the periodic mobile charging, I'm just giving you a brief idea what I'm doing. I'm using multiple MC, and what are the goals is there that we have to design energy efficient traveling trajectory so that charging performance can be improved in the terms of various network attributes like charging cost, waiting time, number of active nodes. So we have to design the trajectory like this. So for that I am using traffic load, routing load of the sensor nodes, and I am just devising an algorithm so that every MC will be moving on efficient traveling trajectory. So that is my primary goal in this work. Main idea: first I am dividing the charging network or charging region into the sub-regions, small regions, such that each region will be assigned one MC to each, and overall load balance should be there. Traffic load balance should be there. I am dividing in such a way that load balancing is there. Second, after assigning MC to each area, I am finding the sojourn points. Sojourn points means stopping points, so that in each stopping point we can obtain an efficient trajectory by connecting them. The MC can move to those stopping points. Okay. Now I am just due to the lack of the time, just I am you can read the details in the paper, which in the publication list I have given. You can read this, the detailed algorithm, but look at the simulation results. Why this is important to understand that the performance analysis in the terms of total tour length and average waiting time is being given, and you can see as the number of nodes are increasing, both the things are increasing. In the case of our algorithm, that is proposed scheme, and the reason is very much clear, because the number of nodes are increasing, obviously the length will be increased, to tour length will be increased because we need to charge more and more nodes. Also waiting time will be increasing because this is periodic. In the periodic we have to cover all the sensor nodes. So as the number of nodes will be increasing, the waiting time will also be increased. While in the comparison part I have taken two other algorithms like Hilbert curve and S curve. Why they are constant? Because they are not depending on the number of nodes. They are traveling on a fixed trajectory, so that their performance is very much low as compared to our proposed algorithm. So that is the main reason. Like this, I have also taken performance analysis in terms of number of active nodes. So number of rounds. One round means the data from all the sensor nodes is flowing to base station. That is one round. So if I am increasing the number of rounds, you can see the number of active nodes will be decreasing, and it is very much clear that as soon as the time will be the major factor to decide, time will be going on and going on, the number of nodes will be die one after another. So we cannot say that is 100% guarantee that all the nodes will work. Some nodes are still dying. But we are reducing the number of deaths. That is the goal. And in the second chapter, if we talk about on-demand mobile charging, I am just using MADM first of all, and considering the objective bit and considering the subjective bit, both I am using. Now problem statement, we have to schedule the requesting nodes. Why I am calling that requesting nodes? Because those sensor nodes which are critical, which are giving the request of charging, only those sensor nodes will be charged. And we have to take a decision. We have to take a wise decision on the basis of multiple network attributes. And for taking the decision, we have to use MEDM, multi-attribute decision making approaches. Now this is a diagram which you can see that there are 4 factors. RE means residual energy, T means distance, ECR energy consumption rate, and nu, that is neighborhood energy weightage. So I have taken 4 parameters, and all the 4 parameters, they are independent to each other, and if I am going to minimize RE, I have to compromise with D, or if I am going to minimize ECR, I have to compromise with other attributes. So we have to make a balance. That's why MEDM approach come into the picture, because we cannot do manually. It is very hard to decide to optimize all the things simultaneously, all the attributes simultaneously. So MEDM approaches, they will do the needful. So in the diagram you can see that RE should be minimum, distance should be minimum, ECR should be maximum, and nu should be maximum. For a better scheduling, we have to make a decision like this only. That sensor node which has minimum RE, minimum D, maximum ECR and maximum nu, that should be the first priority to charge. So I have to take a decision. So the main idea is that we are ranking the nodes based on the charging priority using the TOPSIS. That is MEDM approach. Then we scheduling them, and for the TOPSIS, first we need to calculate the relative weight of the network attributes. So for the calculation of attributes, weights, why it is important to calculate the weight? Because every attribute has its own importance. So I am using both the conditions, like we have to calculate objective attribute weight and we have to calculate subjective attribute weight. Subjective weights they means by manual preferences by the user. What I am giving the preference, that comes to the subjective category. Objective means they are based on mathematical calculations. So both the things I have considered in this, and for the objective weight I am using entropy weight method, and for the subjective weight I am using analytical hierarchy process, HP. So experts decision making we are considering in the HP, and based on the data, mathematical analysis of the data, dispersion analysis of data, we are using the EWM. So that's why both the scheme, they are different, and we have to analyze that which scheme is good. But both are important. Both have its own importance, because both the factors are important. We need to have consideration of both the things. We cannot go only on objective weights. We cannot go only on subjective weights. What should be the consideration? So for the details, you can also, again, you can read the publication. And just briefly, I am explaining the simulation analysis. I have considered three performance metrics. First is charging latency comparison. किया है? That is based on the number of nodes, simulation time. Second, number of dead nodes, which you can see clearly. And third, energy usage efficiency. So energy usage efficiency is very much important because it is reflecting the use of mobile charger in an efficient way. How efficiently you are using the mobile charger, how much energy you are giving to sensor nodes, and how much energy you are providing to mobile charger. What is the ratio of input and output? That's why it is very much important to calculate energy usage efficiency. So that's why you can see as the number of nodes are increasing, energy usage efficiency is also increasing. Because number of nodes will be increased, the amount of given energy to the sensor nodes will also be increased. So denominator and numerator, you can see the numerator is also increasing. That's why we can say energy usage efficiency is increasing. So that is the main reason behind it. Number of dead nodes, it is very much clear. Now in the third contribution, it is based on the fuzzy logic. In the first scheme we are using single MC, in the second we are using multiple MC. Now depending on the area size we can say, or depending on the situations, but if we are using multiple MC we can say it is better than the single MC, because multiple MC can easily charge in the less number of time, but it is very much cost, it is having very much costly, because cost effective schemes are also very much important. It is not cost effective to deploy many number of MCs in a network. So we have to optimize both the things. MC should also be minimum or as the requirement of the area. So what we are doing, we are using the fuzzy logic here, because until the previous work what we are doing, we are just considering the exact decision. But there may be condition that there should be some linguistic terms, there should be some fuzziness, there should be some unpreciseness, because we are collecting the data of the network attributes, and there should be some fuzziness in the data. We may not get the exact data. So that's why we are using fuzzy logic here. So in the solution we are using Mamdani FIS, fuzzy inference system, to quantify the scheduling priority of the nodes, and the scheme will be incorporating 3 network parameters: residual energy, distance to MC, and critical node density. All the 3 parameters will be considered in the fuzzy logic. So what is the main idea behind it? We are deciding the most suitable node for the recharging by utilizing the fuzzy logic. And we are ensuring, what we are ensuring, because the MC energy may not be sufficient to reach the base station, because a node may have a farther distance from the base station. So if you are going to charge a sensor nodes, you should also take in the consideration that MC energy should be sufficient to reach the base station after charging that node, because we have to balance between MC energy and sensor nodes given energy. And after the charging, MC will be updating the network information and again scheduling the most suitable node to be recharged. So in the real time, it is dynamically updating the attributes again and again, and if in between new charging requests will be occurring, then they have to wait for the next charging schedule. We are not interrupting in between, there is no preemption. So we have to consider that thing, because if we are allowing preemption, then it may degrade the performance. So in the conclusion part, I can say that I have developed charging scheduling problem, I have developed periodic and on-demand charging schemes, we have simulated extensively, we have also doing the statistical test. Like you can see in the publication, we have also applied ANOVA and post-hoc analysis for the validity of the results actually. And in the future, we will be now focusing on the coordination between MC and nodes. One MC can coordinate to other MC. One MC can charge to other MC. We can also considering the movement of the MC while moving charging. Because till this point we are considering that a MC has to stop at a point to charge the sensor nodes. But while moving it can also charge. So we have to consider effect of obstacles. We have to consider in this in these contributions. We have not considered any obstacles. We are considering the plane surface. Or we can also consider a combination of full and partial charging, because that may also be useful. So we are considering those things in the future. And these are the references, and these are the brief publications in the list. So there are 4 journals, SCI papers, which have been published on the base of contribution, which I am presenting in this ICDCIT Ph.D. Symposium. There are other papers also you can see in the Google Scholar, but these 4 are mainly based on the contributions which I have presented today. So these are the 4 international journals, SCI, and these are the 4 conferences. So total 8 papers are there, which are basically based on the PhD thesis. Thank you very much. In case of any doubt, you can mail me, and you can found my homepage from Google Scholar also. Thank you very much.